Unit 10, Lesson 5, Trigonometric Expressions. We're going to find the exact value of the following expression, the tangent of arc cosine of 2/3. Recognize that arc cosine of 2/3 simply means at what angle is the cosine equivalent to 2/3. We're going to recall two different things you've learned in previous lessons of this unit. All star trig class means that all trig functions are positive in quadrant 1, sine and its reciprocal are positive in quadrant 2, tangent and its reciprocal in quadrant 3, and cosine and its reciprocal in quadrant 4. Now since we're working right now with cosine, remember that for cosine, the arc cosine, when mathematicians limited the domain, is restricted between 0 and pi. And all of that's going to help here. So here we have a cosine value that's positive. Well, I know cosines are only positive in quadrant 1 and also in quadrant 4. So these are the only locations I can choose from. But then I have to remember that arc cosine can only occur in quadrant 1 and quadrant 2, making quadrant 1 the only option. So I'm going to go into quadrant 1, choose a dot, going directly up that dot, and always back to the x-axis. Remember, the angle closest to the origin is what we are going to evaluate. Cosine is a ratio of adjacent over hypotenuse. So from this angle, adjacent over hypotenuse. Now I need to find this missing length. So I'm going to rely on the Pythagorean theorem. 2 can either be the a value or the b value. It just needs to be one of the legs. And then 3 will be the hypotenuse, or the c value. 4 plus b squared equals 9. I'm going to subtract 4 to the opposite side, taking the square root. And yes, we normally would have a plus or minus in this algebraic equation, but since we know it represents the length of one side of the triangle, lengths are always positive. Okay, so I've taken care of this, and now I need to evaluate the tangent. So this is a two-part problem. What is the tangent at this angle? The tangent at this angle is going to be represented as opposite over adjacent. Let's look at the second example. In the second video, let's start by recognizing that arc sine is the same as at what angle is the sine equivalent to -3/5. Where are sine values negative? Sine values are negative in quadrants 3 and 4. Now, arc sine, when mathematicians limited the domain in order to ensure that the inverse was a function, they limited the domain to be between all the way up to pi over 2 and dropping down to -pi over 2. So when I look at my 2, I'm looking, where do I see an overlap? The overlap is going to occur in quadrant 4. So I'm drawing a triangle, going straight out to some dot in quadrant 4, always back to the x-axis, never to the y, and that angle closest to the origin is what I'm going to evaluate. So the sine is a ratio representing opposite over hypotenuse. Opposite over hypotenuse. And as a reminder, some students are like, what about the negative sign? Negative just allows us to determine the correct quadrant. A length of any side of a triangle can never be negative. Now I recognize this as being one of those special Pythagorean triplets, but if you don't, we're going to go a squared plus b squared equals c squared, substituting 3 in for either a or b, up to you. A squared equals 25, subtract 9, a squared equals 16, and this length is going to be 4. Now what is the cosine of this angle? The cosine of this angle, and I just remembered something from quadrant 1 that I forgot all about. I want to go back up to example 1 after this. I'm tired and still feeling sick, and so anyways, it just spaced my mind. So in this position, what is the cosine? The cosine is going to be adjacent over hypotenuse. But what I have to ask myself is, in quadrant 4, what is the sign of cosines? And we can see they're positive, so I feel confident in 4/5. I do want to come back here. And although I didn't get the problem wrong, I forgot to ask myself, In quadrant 1, what is the sign of tangents? It is positive. And look at example number 3. Recall that this simply means, where can I find an angle where the value of the tangent is negative 12/5? So I'm going to start by identifying 2 of the 4 quadrants where tangent values are negative. Excuse me, that's quadrant 2 and quadrant 4. Now for arctangent, mathematicians limited the input values or domain up to pi/2 and down to pi/2 to ensure that the inverse is a function. So when I look at 2 and 4 and 1 and 4, which one do they have in common? They have quadrant 4. So in quadrant 4, I make a dot out to that point, always back up to the x-axis, and then forget about the negative. What does tangent mean? Tangent means opposite over adjacent. Opposite is 12, adjacent is 5. Again, this is one of those special Pythagorean triplets that hopefully you will learn in time. So one of the legs is 5, another leg is 12, and we want to figure out what is the hypotenuse. So I have 144 plus 25 equals c squared. 169 equals c squared, and I know the square root of 69 is 13. Lastly, let's now identify what is the sine. What is the sine of this angle given the 3 sides? Sine is going to be opposite over hypotenuse. And what we have to ask ourselves is, in quadrant 4, what is the sine? Only cosine and its reciprocal are positive. Example number 4 is slightly more difficult than the first 3 examples. Remember, we can always place 1 on the bottom of any value. It doesn't change that value. And so what does this mean? It means that we're looking for an angle in which the tangent is equivalent to 5 over 1. Notice the tangent is positive. Where are tangents positive? Tangents and their reciprocals are positive in quadrant 1 and also in quadrant 3. Okay, so let's go ahead and then also think about the arctangent. The arctangent, like the arcsine, has restricted domain up to pi/2 and down to pi/2 to ensure that the inverse of is a function. So where do I see an overlap? I see an overlap in quadrant 1. Going to dot, back down. Okay, tangent is opposite over adjacent, so 5 over 1. A squared plus b squared equals c squared. In order to figure out this missing side, which is the hypotenuse and the longest side, 5 squared plus 1 squared equals c squared, so 25 plus 1. We end up with the square root of 26, the square root of 26. Now remember that secant is just the reciprocal of cosine. So if cosine of an angle is going to be adjacent over hypotenuse, then the secant of an angle is simply its reciprocal, hypotenuse over adjacent. So from this angle, the hypotenuse is the square root of 26, and the adjacent is 1. In quadrant 1, cosines are positive. That means its reciprocal is also positive.